Hello and welcome to the Digital Innovation North podcast. This podcast connects technology leaders to ideas, information, and insights that drive digital innovation right here in our region. Our guests are technology leaders from innovative companies and experts from SDG. SDG is Solution Design Group, empowering innovation for over 35 years. Welcome to today's edition of the Digital Innovation North podcast on the topic of responsible AI. We've gathered two PhD-level mathematicians and data scientists who are deeply immersed in applying AI and machine learning to solve big real-world problems. They're highly pragmatic and systematic in their approach to understanding a challenge and building the right solution because they're mathematicians and data scientists. That's how they think. But that kind of sensibility can sometimes clash with the fast-paced world of AI and the urgency of trying to solve potentially life-saving challenges like predicting the next pandemic outbreak. The push to use AI and build a model without sufficient design can and certainly has led to poor outcomes. Without the right foundation, a rushed AI approach can lead to fragile systems, biased results, and costly failures. So, how do you determine if AI is the right solution to begin with? And how do you design an AI model that actually works with real outcomes that are stable and address concerns for data drift, fairness, bias, observability, validation, and maintainability? Let's ask the experts. Joining me today is Susama Agarwala, a mathematician with postdoctoral positions at Oxford and faculty positions at Caltech and the U.S. Naval Academy. She's worked on removing bias from algorithms used by the Social Security Administration and with progressive data groups to understand how race is correlated with access to the democratic process. In her day job, she is an associate research director for Trusted AI, leading a group of AI researchers to build accountable and reliable AI solutions for the U.S. government. By nights and weekends, she is the founder and CEO of Voting Rights Code, building tools to measure and improve inequities in access to our democracy. I do want to note that she joins us today representing herself and not her organizations. Also joining us today is Cam Marcott. Cam Marcott is a machine learning and artificial intelligence engineer with the data science chops to turn models into stories and the software engineering chops to turn research into reality. Cam has conducted model development in education and marketing research and performed model risk management within financial services. If none of that is clear to you, I will help eliminate what all of that means in our conversation today. Cam has a PhD in combinatorics and optimization and leverages his depth of knowledge and ability to apply leading edge technology to deliver innovative solutions to Solution Design Group's customers. He and Susama met when she gave a talk at the University of Waterloo, and they found out that they were very aligned on principle, and they went on to write and publish two math papers together. So Cam introduced me to Susama, and that's how we have come together today. So thank you both for joining me.
Thank you.
Yeah, I
Thanks
look
for
forward to
having
our
us.
conversation, and I know I'm going to learn a lot. So I will play the layperson in this conversation because I am. I am far from a data scientist, and there are definitely terms and techniques and approaches that are completely new to me, but I think are really essential to illuminating some of the important ways that AI needs to be approached. So I think it'll be a good balance. I'll be the layperson and you'll be the experts, and we hopefully will help our listeners better understand how to approach responsible AI. So let's start by defining what is responsible AI? Why is that a term that we're using? And does that sort of imply that there's irresponsible AI? Help me understand, what is responsible AI?
Cam, do you want to take this first?
Yeah, so I would say that responsible AI is like making sure that you understand the problem that you're applying whatever AI you're doing to, and that you understand what your application is and how it's working and how it might affect not just its own model, but the broader system it functions in. And then
Oh,
not just that you understand it, but that you're monitoring it and watching it and making sure it's doing what you're hoping it's doing.
anything to add?
So, yeah, I mean, you said that Cam and I were very aligned in philosophy, and I think that's going to come out in this talk. I think of AI design really as we talk about it as its own thing, but really the principles around AI design is deep in the principles of modeling, which is decades, if not centuries old, right? And there's a maxim among modelers that we say that, all models are wrong. And often in the part of it that sometimes gets unsaid is that some of them are useful. So, and oftentimes as modelers, we use this as a way to be a little bit lazy, which is, another way of saying irresponsible. Um, but if we, a story that I like to tell is, imagine you have a son who loves Legos. And I'm a government contractor. So imagine you, like me, are a government contractor and have been asked by the fire department to help them get a model of the Pentagon so that they can, quickly do what's needful if the worst thing happens, right? And you go out and you write your RFPs and et cetera, and you get one response for RFP, request for proposals. You get one response offering you a Lego set, and you get another response offering you a floor plan. Security concerns about a floor plan for the Pentagon aside, which model do you give to which customer? All models are wrong. Absolutely. But when we're designing our models, we need to have some sort of consideration of which model we're giving to whom, because it would be irresponsible in this case to give the wrong one to the wrong person. And I think that's a lot of what Cam was saying as well.
Yeah, that's a great example. And thank you for making it simple for a layperson. So you bring us right to the question of how do you distinguish between a problem that requires AI and one that could be solved with a simpler approach? Do you have a way of thinking that through or evaluating? Is AI the right tool for the problem?
I tend to favor solving problems with the minimum amount of complexity or uncertainty necessary to achieve the result. So if you have lots of things where people say, I want AI to do this, they might just be they want some process automated in their life. And then you don't even need a model. You just need a standard computer program to automate whatever they want.
Right.
And there's less risk because there's no uncertainty and there's no randomness in the behavior. But some other things, like if you're like, I want something that can finish lines of code for me, then there's uncertainty in what you might write. And there's more complexity in the situation.
Right.
So you need like a Gen AI model type thing.
Awesome. And so you're saying pull it back to what's actually trying to be solved for and what's the most expedient approach, right? So is there
not necessarily expedient, but simplest.
Thank you.
Simplest and most least amount of uncertainty. Because you can LLMs are great, and you can ask them to do anything.
Right.
Like I recently, to see how I guess bad they were, wound up being the result, asked an LLM to give me a weather forecast for St. Paul, and it could pull current weather data from everywhere, and then it gave me a very terrible weather forecast that was it was 20 degrees off of the professional weather forecast, and it was way off on what the professionals thought air quality would be. And then when you looked at what actually happened, the professionals were right.
And why would you even need to bother? There's already a service.
Yeah, but it's easier to it might be easier to ask ChatGPT to do something. So that would win for expediency. Possibly. I'm logged into ChatGPT, it's open. If I go to the weather website, I have to tell it where I live and close 6 pop-ups. So asking ChatGPT is easier.
Right.
But
have you seen an example where
other
AI
things.
That's kind of an example where AI was not needed or large language models were not needed, right?
Yeah.
Have you
even
seen
though
other
they're often
examples
expedient, they're often not the right tool for the job.
Yeah. Yeah, and you even gave a presentation about that whole concept of, could you do this with linear programming or, some other model? Can you talk about that example, Cam?
Yeah, so I was talking about, I'm a big fan of like old school mathematical optimization stuff for, I was specifically talking about batch decision making things. So like I have $1 million that I'm going to spend on putting advertising on TV. How do I pick the best TV programs to spend my $1 million on to make sure the people I want to see my ad are going to see it? And those batch decision making type problems, you can use old school mathematical optimization, which you could also like ask ChatGPT, but the optimizer does what you want, and then it gives a result, but it also like gives a certificate that it obtained the result you wanted. So from a reliability standpoint, it gets a strong win.
Yeah, and that also gets into observability as part of the intention of good design, which
Yeah, that you
you
can
don't have as
explain
much with
how it
AI, right?
worked, or
Yeah. Sushma, have you also encountered places where AI just shouldn't have been used and it just wasn't the right approach?
Yeah. So, well, first of all, I want to kind of back up a little bit because oftentimes, I want to be very careful about what we mean by AI or machine learning because it really depends on what you're talking about, right? Sometimes, um, I have, and I've laughed at them. I have heard people refer to linear optimization systems as AI, which there's an argument for, and I can see that happening. We can talk about clustering as a machine learning technique. We can talk about linear regressions as a machine learning technique. When I'm teaching this in classes, I talk about, your simplest neural network, a one-layer neural network is nothing other than a linear regression. Um, so I want to be very careful and nuanced and not kind of casting all of these techniques in under one kind of umbrella term and then frowning upon it. Like there is nuance and there's layers of complexity. And like what Cam said, keep it simple, stupid, please. So but to answer your question, there was a project, again, there's gonna be a lot of dumping on large language models here, I think.
And that's
So
okay. You're providing one
I mean,
perspective, and there's lots of
right, well,
perspectives.
right, and they are very, very good for certain things, but they're not very good for other things. They're made so easy to use that it's really easy to misuse as well, is I guess what I'm saying. There's a project that I was on where we needed to classify a large data set of radio, or we needed to create a predictor about radio properties. And the issue that we had is that we did not have access to a large data set of the types of radios that we were interested in. We had two choices. We had a large, very well curated data set of old radios that were not relevant for us because we were looking at more modern stuff. Or we could go onto the FCC and try and scrape and put together a data set of the modern radios that we were interested in. And the issue there is that trying to create a data set is inherently a very expensive project. It is always the most expensive part of building an AI system. Well, I won't say that now with the data centers for LLMs. That's different. But like even like 5 years ago, it was the most expensive part of any sort of data of any modeling project. It was creating the data set, creating the correct data set. The so one of the solutions that somebody came up with on the project was, well, let's just ask ChatGPT or to come up with the spec sheets for these radios that we're interested in. So they did it for 100 or so radios just as a test, and we went through and checked them all, and we found that ChatGPT was correct about 13% of the time, which is a
Wow,
really low
that's not helpful.
accuracy rate. No, it's not, right? And one of the things that I made sure of being on the project was to make sure that we actually did have clean data so
Wow.
that we were training a model that was actually useful for our customer
Yeah.
rather
Did you ask
than.
it to cite its sources? Like, why was
Well,
it so
okay,
bad?
I did not, and the reason I did not, well, actually, so it was even worse than that actually, because what we were doing is we were handing it PDFs that we had gotten off the FCC's
Oh,
website.
sure.
And so we had the PDF we had given it, and we had the answer that had given it. And so it was given a point for being marked wrong if it made something up, or if it just misread something from the PDF.
Wow.
Either way.
Yeah.
So yeah.
And it was still that wrong. You fed
it was
it
still
the
that wrong.
sources, and it still,
Yeah.
it didn't even, wow, that's shocking. I've never heard it be that bad. Wow.
I mean,
Yeah.
this was 3 or 4 years ago, so ChatGPT was a little bit newer to kind of, it might be doing better now, but
Yeah.
sorry, it was 2 years ago. But ChatGPT, like it's improving
Yeah.
quickly. So I'm not going to malign what it can do now. I'm just saying this is where it was 2
Right.
years ago.
Right. Wow. Okay. So, and how does that then inform? That's a really good, crisp example of not wanting to trust all your data sources without verifying. So how does that feed into your thinking about, whether it's the right approach or not, in terms of AI or not AI?
So at that point in time, if the decision had gone otherwise and we'd had a much higher accuracy rate, right? There are trade-offs to
Yeah.
be made of, accuracy versus manpower versus cost versus project scope, right? Like there's all of these trade-offs to be made.
Yeah.
So even if it had like a 60% accuracy, at that point in time, I would then go to the project manager and possibly even to the customer and kind of lay out the case and saying, hey, you guys are the customer. This is what we can provide you if we do it this cheap way, or
Right.
this is how we can provide you, but it's going to be more expensive and your accuracy will go up. Which one do you prefer?
Yeah.
And to a
Yeah.
certain extent, as the technologist, as the designer of the AI systems, that's not my call. The
Yeah.
customer needs to be able to make that call. I need to tell them what the trade-offs are so
Right.
that they could figure out whether or not this is what their use case is, right?
Yeah.
I don't ever want to be telling the customer what they should want.
Yeah. Which really does also help highlight the importance of understanding the problem statement to begin with, right? Because I'm trying to imagine in my mind, why did they even want to know about these radios, right? But
Right.
if it's not important that it be precise and they just wanted to have a general sense of geography of where these things are, or, changes over time, or who knows, right? So if you aren't really crisp on the problem statement, then you don't necessarily know how to validate that you've got the right data source that can solve for the right problem, right? So let's switch to the conversation around knowing how to build the right model. You've already provided some really great color for that. How do you approach designing an AI model? If you've met with the customer and you think, yep, this is a good scenario, this is a good use case for AI, it has the right markings of what's going to be useful to be solved by a large language model. How do you move from accepting that premise to design? What are some of the steps that you walk through from problem statement to deployment? Sorry, I know it's a big ask.
I usually try to, from the beginning, try to keep whatever the whole system design in mind is going to be, because often, like when people think modeling and are trained on modeling, it's like, can I predict the future? But often people want to know that because they're trying to make some kind of intervention to influence the future. So like for an example, a project I did for an education company, their goal was to get more of their students passing certification exams. And they're like, well, we could have a model to figure out if a student's going to pass an exam. And it's like, well, it might be an ingredient in what you want, but it's not what you want. What you want is the intervention telling your students study this or helping them improve. So trying to understand what the whole system's going to be, where the model component's going to live. Like I'll have a predictive model telling the student or saying whether a student should pass, but it should also be able to, like I need to design a model where I can poke it and find the student's weak points so I can tell them what to work on. And so that whole system design will inform the type of model where it's like I need a model with some kind of explainability where I can drill down and see what topics are hurting them.
Okay. And so are you saying, and correct me if I'm wrong, are you saying the real opportunity for that customer, the real thing that they wanted to solve for was understanding where intervention was needed? Yes, they wanted the eventual outcome was improvement in results for the student passing, but the real challenge was to identify where the intervention was needed. And so focusing more
Yeah,
of
and
your
not just
energy.
like identify where it's needed, but do it on like a fast personal level. So when you're studying, it tells you like, where does Molly need intervention? And it's just
So many places.
the next thing in your study plan is what you need. And when I'm studying, I get something else. So they wanted it. That's like part of the system design. They want it personalized, tailored to any student, and they want something that they can serve fast enough where if your web page is loading, you don't get annoyed and open a news website.
Right.
Or,
Right. Yeah. And so
yeah, so those are all, you need to keep all of that in mind with the system design, where it's like, okay, I need it to be fast. I need it to tell me what's hurting students so I can stage an intervention.
yeah.
This is the kind of data rolling in, and
Right.
that they expect out if they're like deciding what content to serve a student, and just being aware of the entire context the model's going to function in.
You know, it's so interesting because what I keep hearing you both refer to is understanding the business, understanding the problem statement, understanding the real challenge, and then designing for that. But you're mathematicians and data scientists, and so are you often coupled up with, more of a business analyst or a systems analyst, or are you finding that you're having to actually help architect and understand what is the real business opportunity here?
I mean, can I take this one, Cam?
Yeah.
So I found myself initially when I made the transition really kind of at a very technical level, like where my job really was just to build the model. And
Yeah.
I was not, because of my skills as a mathematician, as you've identified, and I was not pleased with the decisions that were being made for me by the people who were customer facing. So my journey, my professional journey really has kind of forced is a bad word. I have tried to put myself in spaces where I am more customer facing so that I can be having more of those conversations with the customers.
Yeah.
When I was a mathematician, I was very interdisciplinary, as interdisciplinary as you can get in a university, where I was constantly talking to physicists and trying to do the translation from the language they used to the language that I used as a mathematician, because they are very different. And so those skills I found for me, fortunately, translated very nicely for being able to talk to a customer and get their needs and translate them into the needs that I need as a model.
Yeah.
Because if you don't have both at the table when you're talking to a customer, you do end up with bad business decisions. At least that's what I found.
Yeah. That is so interesting. This might be an evolution of what's going to be required for success in AI because it is such a technical implementation. How could a business analyst know the questions that need to be asked that will impact the model, right? And so maybe the data architects and data scientists need to be part of that initial understanding, and engaging in customer focused conversations. Just a thought. Cam, anything to add about how you approach that framing? And Sushama, also, like, you talked about models that you've applied and the NIST model for development and making sure that you're bringing in kind of good, thoughtful approaches to development efforts. Can you talk about some of those sort of formalized models that help you develop your approach to solving a problem?
Okay, so I think you're referring to the NIST AI risk management framework, which came out in like summer of 22, I want to say, which I really love the language that they have developed because it is so simple. It's the three M's, it's map, measure, and manage. So the first stage in AI development is you map out the problem. This is an awful lot of what Cam and I have been talking about. We understand what the problem is. We understand what errors are acceptable and which errors are not acceptable. We understand what the actual use case is, what's going to be the follow-on of, possible adverse effects, possible unintended consequences, all of that stuff, that design work that's painstaking and is expensive and sometimes boring, needs to happen first.
Right?
It does. And you just do your due diligence. And then measure. And so that's the actual, you build the model and then you and you run it in your test bed and then you measure your error rates and you see how it's performing and how that compares to all of the risks that you've laid out in the map phase.
Yeah.
And then manage is really post deployment. So for a more lay audience, it might be worth pointing out that for any modeling, not just AI, but in general, Oftentimes when you're doing modeling and simulation, you have an initial data set that you take the data set and you take a bunch of it out at random being very important, and you put it aside. Um, and you run and you train your model on the stuff that you haven't held aside. And then after you've built it and say, okay, this looks right, you take the data you set aside and you use that to verify your model. So make sure that the performance doesn't degrade, that you haven't done something stupid that you hadn't thought to kind of look. So you test, you train, and then you validate or verify. And then there's deployment. And that's usually on data that you've never seen before and that you don't have access to and no one's ever collected. And you have very little control over there. So the model performance is unpredictable when it's out in the field. Just like with anything, right? Like when I'm teaching students, I can teach them everything I want, and then they go on to the next class, and I have no control over how they're going to teach, whether or not they're going to actually integrate my parts correctly when they go on to chemistry.
Good luck.
Yeah, exactly. So that's what I'm doing with a model. I'm setting it out, go fly, be free, do your thing. But if I don't have some sort of built-in hooks to be able to monitor that, to collect the data of what it's seeing, to measure its performance, and that could take a variety of forms depending on what the application is. I don't have a way of recalling the model and say, oops, it doesn't work well. We do this in other industries. In the car industry, right? Like if the seatbelt doesn't function or if a brake doesn't function because of some weird something with the floor pads, we have a way to recall the cars.
Right.
That data is collected. That's the manage phase. That data is collected. That data is reported. If it hits above a certain threshold, the car gets pulled back. If my Cybertruck is blowing up, we can return my Cybertruck and get it dealt with, right?
Right.
I don't have a way of doing that for a AI model. So, going all the way through the lifespan, not just, from when the customer gives me a need, I map. When I'm building it, I measure. And then when it's deployed, I still need to manage it somehow.
Yeah.
And that involves measuring it and setting up the observability.
Absolutely.
It's big.
Yes.
Oh my gosh, I have so many questions.
And then you also need to not just observe outcomes, but you can, if you have a model that is letting itself learn and adapting itself, it could influence the world it's learning on.
Mm-hmm.
So if you're a social media company and you're trying to pick what content to serve users based on what they like, and then they start liking things based on what you serve them because your model decided that, you've built an echo chamber.
Yeah. Because as you were describing,
desirable. Sorry.
Yeah. No. As you were describing, you can't pull it back. You can't recall it like a car. I was like, well, why not? You just explained it, Cam, because it's out there in the universe and it's gesticulating on itself, and so it's getting modified in use. Is that what you're saying?
No.
In other words, why can't you just go back and fix the formula, fix the algorithm? Why can't you recall it?
Because the way that things are designed and built now, there's no way to see whether or not it's performing the way I want it to perform. Because the model is giving an answer. Yeah. It's not and we're just like so the way that let me back up. So in the training phase, the way that
and maybe give me an example, like a data set for something. Okay. This is hard stuff, right? As a layperson, I'm like, no, not getting it.
That's fine.
So thank you for slowing down for me.
So a really famous data set that people really love working with because it's very simple and intuitive is the NIST. It's MNIST. It is NIST, which is the National Institute of Standards and Technology, which is the same organization that came up with this AI risk management framework. They built a data set of numbers called MNIST. Not sure why it's M. It's the number 0 to 9, and everyone uses this. It is an incredibly popular standard to train classifiers on, and to kind of teach and whatever and whatnot. And so one of the things that happens from MNIST and several of its cousin data sets is that you train a model to learn how to read numbers and maybe letters. And then one can imagine, I don't actually know of any company doing this, but it seems like a reasonable approach to take from an engineering point of view. I've trained my classifier on MNIST and something else that gives me letters. I set it out in the real world, with the job, with a little bit more engineering, and it now has the job of identifying license plates. Now, at that point in time, there's a whole lot of other factors that have been causing errors. And so if it's going through and identifying a license plate and there's a smudge, and as a result, it reads a 6 as a G, I have no way of knowing that the model is wrong. The model has no way of knowing that it is wrong. All I know is that on MNIST, where there aren't any smudges on the cameras, it's pretty good at identifying a 6 as a 6 and a G as a G.
Right.
Does that make sense in terms of why
So
I
you're talking
can't
about like a
recall it?
scenario of like, traffic enforcement or something, finding
Something,
speeders or something. Yeah.
Yeah,
So
or like fraud detection is a big one at banks, where you can train a
Yeah.
model to spot fraud, but everything that your model says that looks safe, it's just going to be let to pass through the
Yeah.
transaction. So you'll never get any feedback on if you missed
Mhm.
fraud, unless
So-
something bad or catastrophic happens. But
Okay, so again, I apologize for being such a layperson here, but wouldn't you just do sampling? Wouldn't you just do, random testing, even with a human, to every once in a while go, did the license plate match with the reality? Just like in a manufacturing process, you would want to occasionally do some quality analysis, that kind of a thing. Wouldn't you build that into the model?
Sometimes you do. I would call that responsible use of AI.
Okay, good. Let's
There's
go
a-
there.
yeah, but
There's a phrase called human in the loop, right? And
Uh-huh.
that's there specifically for that reason.
Yeah.
But if you
Yeah.
don't, for whatever reason,
Yeah.
then you don't have that hook.
Yeah. And so is that part of what you would talk about when you're saying, good design? You talked about mapping the design, measuring the design, and then managing. So is that in the measure phase of like you're going to build it to include some sort of validation approach, or talk me through what does the design look
Sure.
like? Okay.
So I would call that actually in the map phase.
Okay.
Because what I want to know when I'm trying to design something, so let's take Cam's fraud example, right? The thing that I care the most about, like what he said, is that there's a whole lot of false negatives that just don't get flagged, because what it's doing is it's flagging, it's flagging positives, a positive being, hey, look, fraud,
Yeah.
and then maybe there's some false positives, and what the humans will be able to do when a human gets told here's the fraud,
Right.
and then they get told, and then they go take a look at it and say, is this actually fraud or is this not fraud? I'm presuming, Cam, please tell me if I'm wrong.
Yeah.
And so then you're able to catch the false negatives, sorry, the false
Yeah.
positives in that case. You're able to catch them because of a human doing that. But the false negatives, because it never brought to human attention, they just fly under the radar.
Mhm.
So at some point in time in the map phase, I need to have some sort of idea for, in a lab setting, on the lab data that I have, what's an acceptable false negative rate, what's an acceptable false positive rate, and then I can, in the lab where I actually have labels to see whether or not my model is right or wrong,
Mhm.
and in the lab I can actually test for that. And then if my data is not representative, which is a technical term, but basically what that means is that the data that I'm training on does not look like the data that I'm going to see in the wild. So going back to the MNIST, my MNIST numbers are never going to have a camera with a smudge on it.
Right.
So my real world data that could have smudges looks different than my MNIST data does. That's when I started running into issues because I haven't tested for the smudges.
So interesting. Okay, so you plan for that analysis and validation within the map phase. You've talked a little bit about data drift as we were prepping for this conversation. Is that the concepts of fairness and bias and data drift, is that also incorporated into that initial modeling
Yes.
phase or that design phase?
One would hope. Again,
One
going
would
back
hope.
to your
How do you
original question
how
of
do you plan for
responsible,
that? How do you
right?
design for that?
Um, Again, it's a question of what it is that you care about, and whether or not the aspects of the data that you care about. Okay, let me back up and start from the beginning of the sentence rather
These
than
are
the
not
middle.
small questions, right?
This is going back to, I think, what Cam and I have been talking about this entire time, which is, what is the model actually being used for? Are we building something for what we're using
Yeah.
that's actually important? So people oftentimes talk about biased data sets, and I don't like that term. A data set is only biased if it is not suitable for the use case that we have at hand. So for instance, if I have a data set that has a whole lot of very rich information about white men over the age of 50, and I'm trying to use it to kind of figure out, candidate popularity in a certain part of the country. Yeah, of course that data is biased because it's not representative of the population that I care about sampling and understanding. But if I'm using that data set to understand colon cancer, that's not biased at all. That's exactly the data set I might want.
Yep.
So really making sure that what I'm feeding into the model and the strengths of the model are appropriate for the use case.
And what is this thing about data drift? What
Oh,
is
I'm
data
sorry.
drift? That's okay.
Sorry.
No, you're good.
So data drift is where if my data set that I'm looking at does not, along certain characteristics that I care about, does not. So okay, so in the test setting, if the data set that I'm looking at does not match the data set that I'm going to be deploying on, or as sometimes happened, and this is to a certain extent what Cam was saying with the social media, because time happens or because the model actually influences the universe or for whatever reason, the data set that I'm looking at starts changing in key characteristics. So,
yes.
If my data set is climate data, and I have a lot of really good data for the last 200 years, which I don't think we do, but whatever.
Let's imagine.
Let's just imagine. And I know that, and then I use that to predict what's going to happen. Of course, my data is going to be wrong because the state of the universe means that my climate is changing right now.
Yeah.
And therefore, the data set that I had from 200 years ago to 100 years ago is not as relevant as the last 50 years, which gives me a better idea of what the trends are.
I can definitely understand the design there, the importance of understanding your data set so that you can account for the relevant representation, that it has to be actually targeted. And so the drift in that scenario of climate change is that there's a change in the data set that actually needs to be accounted for as relevant, because there's been so much change. There's an exponential increase in certain factors within our climate over the last 10 years. And so you're saying that that data drift needs to be understood in your data model so that you're actually valuing more recent data more than you're valuing historical data because it's relevant for that scenario. Yeah.
Because the data, the relevant data is changing, right? The features of the relevant data are changing.
Yeah, really good. I'm actually going to share a little bit about why we wanted to talk about this. As an organization, Solution Design Group, we have AI experts and machine learning experts, and we talk about internally what do our customers need right now? What's important? What's relevant? And how do we approach this evolving market space in a way that has integrity for us as an organization, and we think actually best serves our customers? And one of the sort of not sexy answers coming back from our technologists is sometimes it's not even the right answer, and customers want the sexy answer. They want to do the cool new thing and be able to say to their shareholders or what have you, oh, we did this cool AI thing, or we've got this chatbot or whatever. And so internally we're having these conversations about how do we really best serve our market space with ethics, with integrity. And so we really wanted to have the conversation today about what does it mean to be responsible in this evolving ecosystem of AI, and how do we help our customers understand why we might want to go slower in that design phase, why we might want to be that much more thoughtful about even selecting the right approach and the right solution. And so thank you for spending some time with me to help me better understand how really important it is to approach these opportunities and these challenges with our eyes wide open about the risks of not effectively doing design at that front end phase. So coming back to that question then of really even selecting the right approach and whether AI is the right answer, when you think about projects that you've been a part of and things that you've seen that have gone wrong, I mean, there's some pretty expensive failures out there where people approached building a model, approached, delivering an AI solution, spent years and years and millions of dollars, and frankly, a lot of energy, right? That's one of the impacts of AI is just the cost of running these data models. What are some of the examples that you've seen of projects that went wrong, and why did they go wrong? What should they have done differently in their approach?
So I have a story, unless Cam, you want to jump out
Yeah.
onto this.
No, you can tell yours.
Okay, sorry.
Let's share some dirt.
I'm not going to share any dirt, but I'm
Right.
also a storyteller at heart. So, so this was early in the pandemic. And the CDC had contracted my company to build a model to predict where the next pandemic was. And I think you referred to this in the intro, or where the next outbreak was going to be.
Yeah.
And the CDC had asked us to do the thing that is very commonly done of, we are hiring you to build a suite of N models, N being somewhere between 3 and 7, right? Some moderate number of models. And we're going to see which one performs the best. And that's the one we're going to choose. And it's considered a form of risk mitigation, because if I put all of my eggs in one basket, maybe that basket isn't going to work. So I was on this project. It was late 2020, early 2021. It was important that we be able to understand this because the world was on fire. It really was.
Yeah.
And there were 3 models that were taken. One that was being designed by somebody who had not only a PhD in public health, but had taught at the Bloomberg School of Public Health at Johns Hopkins University for several years, and then had come over to our company. There was a Bayesian network that was being built, that I was in charge of, and then there was a regression model that somebody else was building. So those were our 3 that we were going to build and then hand over to CDC, whichever one worked best. And I very quickly realized that the Bayesian network was the wrong model to be building. And the reason there was a wrong model to be building, this is again going back to the design decisions, it's slightly different than the conversation we were having. The mathematical assumptions that model makes did not hold in the data that we had on hand. To get a little bit technical for a second, the assumption, the Bayesian network does everything based off of conditional probabilities. So based off of, if I ask you in general, are you a boy or a girl? I have no idea. I'm gonna say 50-50, right? If I say, or maybe 45-45-10 to kind of include our trans friends. If I know that your name is Jane, are you a boy or a girl? Those numbers are going to change drastically. That's a conditional probability. And right? So if I have some information, what do I know
Could
about
influence your conditions.
Right, exactly.
Okay. Yeah.
So the question then becomes, so a Bayesian network requires this knowledge in order to work. We did not at that point in time know any of the conditional, how any of the variables that we had. It was just too
How do you build a
early.
model
We
when
just
you
did
know
not
nothing?
Well, that was part of the problem, right? And I mean, the public health person did know an awful lot because he's an expert in the field. I'm not a public health person. I was brought on as a mathematician and an expert in modeling in general. So we weren't able to, the Bayesian network did not work. And I could have told them this did not work. The customer did not want to hear it because, again, everyone was panicked at that point in time. It was a really scary time.
Do stuff
but
quickly.
Right, exactly.
Fix this.
There was a lot of time and effort and money that could have been spent on a better method if that careful design had been taken into account early on.
Right,
Does that
right.
answer the question?
Yeah. Even though I know nothing about those model types that you suggested. No, that's really helpful. And it's certainly something that we all lived through. And so to have that kind of understanding of what was happening on the back end of like trying to solve for, anticipating the next outbreak, that's just, first of all, amazing that you were involved in that work, and really appreciate that example because that does really help understand you're building different models based on certain model types that a layperson wouldn't necessarily understand. And so even just choosing the right model type for the problem statement, makes a ton of sense. Excellent.
Maybe give as an example for
Yeah.
not so much a specific example, but another history lesson. For a while, I worked in model risk management at a bank. So this is an industry of like looking at what models are being used by a bank and evaluating how much risk there is tied to them based on like how uncertain the model is and how high of an impact it has on things. But the reason this whole industry exists is there was a lot of not the best modeling practices played a large contributing factor to the 2008 stock market crash. There's like a lot of lazy modeling and like miscalculating how much risk was tied to certain portfolios.
Wow.
Like essentially helped crash the economy in a big way. So the federal government stepped in and told banks, you need to like manage the risk that comes from all of your modeling practices. So banks are forced to do this. And they tell them like, you need to institute basically an internal peer review process on any modeling that happens and grade how important it is and how risky it is and submit all of that to the Federal Reserve Bank or the Office of Comptroller of Currency, depending on.
Wow, that absolutely makes sense. And I didn't know that either. I think that's really, again, something we all lived through.
But
and
that was a very expensive mistake on the behalf of the whole banking modeling industry in 2008, expensive for all of society.
Wow. Wow. So if you could redesign how companies, I was going to ask if you could redesign how companies start an AI project, but really these are data problems. It doesn't necessarily matter that it's AI or linear regression or whatever. It sounds like there's an opportunity for more technology oriented data scientists, more technologists to be involved in problem solution design. I think I want to rephrase this. It's weird that problem ever happened to me now in hindsight, that the model was so poorly designed. So couldn't somebody at your level have looked at that and said, this is not accounting for all the right things? We're at risk. How do we proactively do better to identify that a model is not correctly accounting for what it's supposed to account for?
Like everything, like nobody has time to do everything. So at some point you need to set a standard for what's good enough for any project. And I think it's just being more careful about where you set that standard. If it's like a could crash the global economy level risk, you need a very high standard. But if it's like, what ad are you going to see on Facebook next? That's
right.
I guess that can do real damage to society, but it's maybe a different risk standard.
Yeah.
So my husband for a while worked as a USAID contractor. And one of the things that he would say whenever he got into, again, as a data scientist, and one of the things that he would say to the customer, to USAID, whenever he got into the room with them, is that you need to help us be incentivized properly. So if you actually want us to be able to have set aside the money to do proper randomized control trials, so you have confidence in the fact that the programs you're funding are having the effect you want them to have, then you need to give us the money. Right, one of the as a defense contractor, right? I mean, it has to be part of the program budget. Otherwise, we can't. Right? And this is not pointing fingers at anyone. I have a really hard time advocating for careful design because yes, the risk is high, but no one's doing the expected value calculation at the end of the day. No one's actually saying, well, how large in dollar value is the risk and how likely is the risk to happen, and kind of doing that calculation at the end of the day. So it goes to the cheapest bidder, which is the cheapest bidder that doesn't have that part of it designed in. So the incentive on me is to get things out fast and cheap.
Yeah.
Because that's what the customer and the client wants. And I'm sure that's what you're facing at SDG as well, is that the customers want fast and cheap.
Yeah. But it also needs to be good. It needs to actually have the desired outcome.
Well, it needs to be better than what they have.
Right.
And better could mean a lot of things, like maybe quality goes down, but there's less humans deciding things, so the price went way down. Like we'll
Right.
accept lower quality for way lower price, or
Right.
maybe quality goes up a little bit, but it's not perfect.
Yeah. You're talking now about the outcomes of all the work, right? Does the product actually deliver the intended outcome, and is it providing value, and is it sustainable and maintainable? And you talked about that sort of managing and monitoring phase as sort of step 3 in the design from NIST. How do you build from the beginning so that you know that you've got the measurement of this is working? How do you monitor that it's working? How do you build that in?
So there's all sorts of ways to build in monitoring hooks, if that is, again, if that is what the customer wants and is willing to pay for. Um, then again, it depends very much on the use case. So anything from having a human on the loop or in the loop to kind of provide some sort of feedback, anything from monitoring on, sensor performance, anything from, random sampling of the measurements that it's taking and then going through and checking it, having a human being check it.
Right.
There's the ways are numerous, but again, that discussion has to happen up front
Yeah.
so that the code that needs to be written in order to implement that feature can be written
Right.
during model development.
Yeah.
And what are we monitoring for, right? Like,
Right.
is also part of that discussion that needs to happen, is that, right, are we really careful, or do we really care about the false negatives? Do we care about the false positives? Do we care about some combination of them? What are
Right.
the, do I care about, what type of bias am I concerned about? What do I want to catch? What do I want to flag? Um, I mean, it's like with any, like, and we talk about this in AI, but it's like with any other software system, which is maybe less scary to talk about. Software engineers will always talk about unit tests and error flagging and how important it is and whether or not the right level of error flagging is in the code. That's essentially what I'm advocating for here.
Yeah. Yeah.
Right. And then there's different similarly levels of logging or observability that can happen
Yeah.
with software, depending on like what people
Yeah.
want to pay for. It's a lot of what it boils down to.
Cam, you've mentioned in previous presentations the importance of observability and then therefore sometimes why AI is not necessarily the best tool. Can you talk a little bit more about observability and how that fits into making a good decision about the right tool?
Yeah, so there's like recording if you have a model predicting something, like what's it predicting versus what actually happened. Um, and then, so that's something like a basic observation you would want to make. And you might want to make observations about how is a model making decisions. Then you would go to, you'd want something more explainable. Or you might, if you have a model making decisions independent of model quality, you might want to observe, like, is it treating different people differently? Because
Mm.
I don't want a model, like, if you have a model approving loans or something, you don't want it to reject all the loans from a protected class. Um, so
Yeah.
you'd have to record like who's in a protected class or whatever you care about, and like look at, is the model treating this group of people differently than the rest of the population,
Huh. So you
which
would
it
build
can
in
do
a
even if
test into the code to do some random sampling, or how would you design for that? Or is this where the human in the loop comes back?
it depends on what kind of data you have. You don't necessarily need a human in the loop. So if you have like a data field that's like belongs to protected class, true or false,
Hmm.
um, you don't want to train your model on that, but you want to keep it there to look at.
Yeah.
You just sort of segment them off, and like both the major cloud services have dashboards that are relatively easy to set up if you have these variables, and you can have like a good looking dashboard you can show a business person with
Oh, nice.
um, minimal engineering work if you have the data and model in place.
Yeah.
Um, but if you don't necessarily have them, there's like a very good treating different races of people differently. Airbnb had an awesome project. They called it, I think, Project Lighthouse. I don't know if it's still going, but they had like, because they wanted to, they have their AI stuff, but they're also want to monitor. There's like ways they design their system, and like as an Airbnb host, you get to pick who you're hosting, or you get to pick what reviews. So they want to monitor, like, are we designing a system that does not enable other people to be discriminatory? And they set up a very robust experiment design and to let them monitor these things about their system. And they've published papers and like open sourced everything they did around that.
That's really
awesome.
cool.
Yeah, Project Lighthouse. That's a good, if you want to read like a 60-page paper about how Airbnb does.
You probably do, because you're both data nerds. I love it. Yeah, send it to me, Cam. I'll read it over the weekend. Not.
Get ChatGPT to summarize it.
Right,
oh God, don't even get me started.
I know I'm asking you guys hard questions because there's so much behind the answer, right? You're having to really simplify and reduce down in order to provide something that a layperson can understand. So I really appreciate the effort of the conversation and the ability that you're bringing to help a layperson better understand some of the pitfalls and risks of poor design and some of the ways that we need to help our customers think about good design and really approaching design from the beginning to ensure the outcomes are achieved and measurable and managed, and avoiding some of those risks of bias and fairness. And so I do, the conversation has really left me thinking about the responsibility that we have to our customers to making sure that we have that thoughtful approach. And it seems like, you'd made a comment earlier, both of you, about how there is the importance of taking into account what the customer wants. But we also have to advise the customer, like, yeah, we could build that and it won't give you what you want, right? We could build that and it won't be sustainable. We could build that and it may have data drift. And so I think it's really important that we're all mindful of the importance of advising and helping our customers come to trusting that the design really needs to be very well thought through and really with responsible AI in mind. In the conversation we've had so far, have we missed anything that you want to make sure that we highlight for folks listening about the importance of approaching the design phase for good, responsible AI?
I don't know that we've missed anything.
Susama, you had talked, sorry, you had spoken in one of our preparation calls about the work that you're doing in voting rights. And I wondered if there's anything that you wanted to share about any scenarios that you've been involved in where you were able to help bring some tools or some measurements to improve inequities in terms of access to democracy. I know that's a big focus for you. Have you found anything really helpful?
So the thing that I love about, I mean, one of the reasons that I went off and made my own organization here was because it was an opportunity for me to serve a clientele that really did care about these issues of disparate impact. And this was a community that wanted, like, whatever we hear on the news shows, my experience working with election officials is they really do want to serve their people. Like, that's why they're in their positions. They're not partisans, they're not whatever. I mean, there's maybe a few bad apples, but which industry doesn't have a bad apple, right? So by and large, they've wanted to understand how to improve their systems and better serve their people. So being able to say, okay, here's how you're doing on average in your county, and here's how you're doing by population density in your county, and here's how you're doing by race in your county, or here's how you're doing by age in your county, and this is how you can improve, which of these demographic differences is most important to you for your people and your population. Right. Which ones do you want to help serve most?
Yeah.
And being able to kind of provide them with a menu of options to improve that, so that they are so that they can serve their people better, or even or just to say, okay, you've done a ton of work and it's all been qualitative, or and now let me give you some quantitative numbers to help you understand the work that you're doing. By the way, I will not call optimization AI. So there's no AI in this work that I do. It is all optimization work.
Gotcha.
But then the data analysis on it
You're
really
less of a
does.
shill than me. I'll call it AI if it
I,
like if a customer wants AI and
if
optimization is the
customer
right tool for the job, I'll let them think it's AI all
absolutely,
day long.
right? I've called all sorts of things AI for a customer that I've need because that's what they've wanted to hear, and that's what I've needed to say to get the job done, and that's totally fine.
Interesting. That
And
is so
absolutely.
interesting.
But the AI, but here it is an optimization engine at the end of it. And the thing that I do that is different is I do break things out by the features that my customer cares about, which in this case is the county election official or is the kind of advocacy group, which oftentimes is to break it down by demographics and tell me what the disparate impact is on these different things that we want to protect, these different categories that we want to protect. Right. So
yeah, interesting. Okay, and so now I have to ask the question. This might be a little off topic, but you said it's really optimization. I'm not going to call it AI. Cam says, well, maybe blah, blah, blah. I didn't realize there's that much, fuzziness about what is artificial intelligence. So maybe that's a whole nother podcast topic. But I would, as a layperson, say that artificial intelligence is when it is learning from itself, when it's leveraging whatever data sources, whatever model to improve itself or learn from itself, versus it's a discrete set of data that we're applying programmatic something to and producing a result. So it's not necessarily learning from itself. Am I wrong as a and if so, I'll just edit out that part.
I just kind of code switch and use whatever word whoever I'm talking to is using. Like if they're saying machine learning, I use say machine learning. If they're saying AI, I say AI.
Fine. Yeah. Can I give a history lesson?
Yeah, please.
Okay. And Cam, please jump in at any point in time and add or correct or whatever you feel like you need to do. So there's back in the 90s, 80s, there was really kind of the first wave of AI, which was symbolic AI. It was all rules-based AI. And I think maybe optimization might possibly fall in there. Where it really was all about, really complicated rule sets that were beyond what a human being could necessarily understand, in one go. But you can code them into a program, and you could give it a data set, and it would tell you what to do, or it would give you a classification or whatever it was that you needed it to do.
And it's a unit that you could bring into your structure, is what you're saying. I mean,
it's like a decision tree
like
that's
Lego.
Too big for you to follow.
Exactly. Okay. Yes, there we go. Yeah. And so that was, and that was very traceable and understandable, because you can go back, like, even though you couldn't understand the entire decision tree, you could go back and follow the steps backward for any decision and understand how you got there.
Okay.
Okay. And so that was symbolic AI. And then the second wave of AI has become the kind of the statistical wave of AI, where, I will put linear regressions in here, even though linear regressions are very explainable and understandable, but it's all about finding the expected outcome. Right? Like what's, because it's not, there's no decision tree. It's looking at a whole bunch of data and it's saying, given this data, what's the pattern that I seem to understand, to have learned from the data, and what do I expect to be the output for a given input, given everything else that I've seen?
That just seems like programming.
No, because programming will say, okay, given this output, there's one and only one input you could possibly have, right? What I'm saying here is, let me go back to the example that I had before. If I have to predict gender, male, female, other, okay, and I give you a name, Jane, then you are going to predict female, because that is the most likely outcome. It could be other, but it's more likely to be female. If I give you the name Leslie, you're going to be a little bit more uncertain, but you're probably still going to say female. If I give you the name Joe, similar, you're more likely to say male, but even though it's not, you're not guaranteed
Yeah.
to be correct, right? Like
Right.
you're taking an expected outcome
Right.
rather than in the programming sense or in the symbolic sense, there really is a pathway that gets you to the decision that you're getting at. Does that
Yeah.
distinction make sense?
Yeah. Yep.
So that's the statistical wave of AI, which is kind of the second wave of AI.
Okay.
And then we're kind of in the third wave of AI, whether you want to call it neurosymbolic or generative or something else, like that's still to be defined.
Oh, okay.
So when you hear third wave, that could be a,
And that's kind of what I was saying, or what I was
Right.
thinking is AI
Yeah.
is when it's learning from
Right.
itself. And okay.
Yeah.
Very helpful. Awesome. So Cam, you think that if it's solving the problem and they want to think that it's AI, we can just let them think that it's AI? Because what was just described could you could use linear programming to solve some of that, right? You could use other models to solve.
Yeah, I am not that picky about those definitions. There's other definitions I'm very picky about, but there's often like, a company like wants to do an AI project and they want like their marketing team wants to talk about it or something. And
Yeah.
like I'm not the marketing expert or marketing person. So they kind of know what they need to do, and
Yeah.
like I'll talk to them and make sure they don't say anything false, but
Yeah.
being nitpicky about vocabulary doesn't rise to my standard of like correcting falsehoods.
Yeah. Which brings us back to the that you guys are pragmatic. You're trying to solve the actual problem and helping really ensure that the design results in the solution. So thank you for helping highlight how deeply intentional design and mathematical rigor and disciplined problem framing can prevent bad outcomes before they happen, or just not getting the outcome that you wanted at all, right? So we're framing that up as responsible AI, and I really appreciate you helping us to frame that up for our folks listening. So thank you for joining us on this episode of the Digital Innovation North podcast. If today's conversation sparked ideas or raised questions about your own organization's use of AI, we'd love to help. At SDG, we offer an AI readiness service designed to elevate where you are today, help you define what's possible and what's practical. It's structured, low-friction way to assess whether AI is the right fit and how to design a solution that's fair, resilient, and built to last. You can learn more on our podcast webpage and at solutiondesign.com. Until next time, thanks for listening and stay curious. Hey, thanks for joining the Digital Innovation North podcast. For more SDG insights and access to all of our podcasts, please visit our webpage at solutiondesign.com.